All right, so here for example 2, we're dealing with common logarithms. Logarithms with base 10 are called common logs. The subscript 10 is often dropped. So a logarithmic statement with no specified base is understood to be base 10. So if we don't have a base written, what base is it? 10. It's one of the very few times that something is not written, it's not going to be a 1. Okay? So if no base is written, it's base what? 10. All right, so example 2 says evaluate the following logarithms and exponential expressions. So we're doing the same thing we were doing. The only problem is it didn't tell me what it's equal to, and that's what we're going to try to solve. So remember our two different forms, or if we're in log form, it's log base b of x, and we set it equal to y, correct? Whoops. And if it's in exponential form, it was b to the y, and we set it equal to x. So the first thing I do when I go look at letter A here in example 2 is this in log or exponential form? It's in log form. So it's going to be set equal to which variable?
Log y.
It's equal to y. And I'm going to do the same thing I just did. I'm going to list out my pieces of it. So looking at my log form, going across it, what is my base? It's not written, so it's a 10. What is my x? 100. And what is my y? Alright, so when I go to solve this, then I've got b, I'm changing to exponential, remember, so b, which is to the y, which is equals x, which is, now some of y'all automatically know the answer. 10 to the what equals 100?
17.
All right, never mind that statement about some of y'all are going to know the answer.
10.
Yeah, I know, that's why I said never mind. All right, so there's different ways to work this, but the easiest way is to get like bases. Can you take 10, always check, can you take the larger number down to the smaller base? Can I take 100 down to a base of 10? Yes, it's 10 to the 2. 10 to the 2. So, I know that 10 to the y then is going to be equal to 10 squared. If your bases are the same, guys, you can throw them out because they're already equal, which means your exponents have to be equal. So we know then that y is equal to 2.
Oh, wait, so we just solved it?
Yes, we're just solving it.
We solved for y?
Yes, because that's what we're, log of 100, we want to know what it's equal to, and it's equal to y, so we need to solve for y. So let's look at b. It's in log form, so we're going to let it equal which variable? Y. So I'm going to go through and list my pieces. What is my base? 10. It's not written. Of, what is my x? Square root of 10. And what is my y? So now I'm going to set it up in that exponential form. So b, which is
How do you know it's 10?
to the y equals square root of 10, right? How do I know what's 10? The base? Is there a number written for my base?
No.
So we automatically know it's going to be a base 10. It's just like if an exponent's not written, we know it's a 1, right?
That's for everything?
That's for all logs.
Oh,
For logs. If the base is not written, it's a base 10. All right, well, I can't take 10 down to a square root, but I can take the square root of 10 and make that exponential, right? We just talked about that. We did a little refresher earlier. So I'm going to keep my 10 to the y. How can I rewrite the square root of 10? Yeah, that's, remember, your base raised to the exponent, which is a 1 because it's not written, over the root, and it's a square root, so it must be a 2. Now your bases are the same, so y is equal to 1/2. Remember, if your bases are the same, then your exponents have to be equal as well.
I did not understand that.
Which one? Changing the square root of 10 to 10 to the 1/2?
Yeah, I don't know what.
All right, because we had that rule that said if you have a base and it's raised to a fractional exponent, then that's the same thing as saying the root of that base raised to its exponent, okay? And that E is for exponent and the R is for root. And so when we had that square root of 10, my root is 2 because it's square root. My exponent's a 1 because there's no exponent written, right? So using that above, I know my base is 10. My exponent is a 1 over my root, which is 2. So I was able to rewrite it.
So what was in the fraction on the first one though?
Because our first one was 100, which is the same as 10 squared. We didn't need to get rid of the radical. There was no radical on it. All right, letter C. What is my, well, first this is in log form, so we're going to set it equal to what variable? Y. So what is my base on C? At 10, because it's not written. What is my X? 1 over 1,000. And what is my Y? All right, so I'm going to set it up in exponential form. So B to the Y equals X. What's wrong with this problem now? We have a fraction, don't we? So remember we talked about the negative exponent thing? Makes you send it to the bottom. And back when we had talked about it before Christmas, we had said that anytime you move something across a fraction line, it changes the sign of the exponent. So what I can do is I can move this 1,000 up, but that 1,000 is raised to the first power, isn't it? So now it's going to become 1,000 raised to the negative 1. And then this is like A, I need to get like bases. Well, 1,000 is the same as 10 to the what? Yeah, negative 3. Well, let's just say 3 first, okay? Because, guys, with 10, it's easy. Count the number of zeros. 100 is 10 squared because it's got 2 zeros. 1,000 is 10 cubed because it's got 3 zeros. 10,000 would be 10 to the 4th because there's 4 zeros, okay? With 10s, you always count the number of zeros. But now on this one, we have 2 exponents. So we're going to have to multiply those exponents. So really we have 10 to the y equals 10 to the negative 3. And now my bases are the same, so I'm going to get rid of them. And so y is equal to negative 3. Which means that log of 1 over 1,000 is equal to negative 3.
So with the negative, you got rid of the fraction?
Negative got rid of the fraction, yes. And what about D?
What about it?
What form is that in?
B to the y equals x.
Yeah, that's exponential. So that's b to the y equals x. So we're going to put an x there. So now I'm looking at the second form when I label my stuff. So b to the y equals x. So what is my b? To the y. What is my y? That's that log base 6 of 6, right? Equals x. What is x? All right, so we set it up into log form now. So we got log base b of x equals y. Well, a couple things we're going to have to work here. Do I have to write base 10 on the left there? No, so this is just log of x equals, but wait, log base 6 of 6, I can probably work that out, can't I? So what is log base 6 of 6? Yeah, if you don't know those properties, you can come over here and say, well, log base 6 of 6 equals y. Do the same thing we've been doing. So my base is 6, my x is 6, and my y is y. And so b to the y equals x. Remember, this is 6 to the first. My 6's are gone, so the y equals 1. So log base 6 of 6 is the same thing as 1. But I still didn't solve for x, did I? No, and actually if I'd have done that to begin with, that would have made this problem a little easier, I just realized, but that's okay. So now we can take it back to exponential. So when I go to take it back, what is my base?
10.
What is my x?
10.
And what is my y?
1.
So b to the y equals x. So what is x? Yeah, 10 to the first, which is 10. And honestly, guys, if I'd have done that at the beginning, I'd have had 10 to the 1 equals x right there. I didn't catch it, though, until we had already started working. Because a lot of times we can't work it. We have to solve using a one-to-one property.
Now you just